Okay, today we're going to take a look at a Six Sigma project charter. Project charter is an important part of the define phase in a Six Sigma project. Basically, this project charter just serves like a contract that lets everyone know what is expected from the Six Sigma project. And we've got a template here that's going to help guide you. Most companies modify a template, have their own template, have different pieces of information on it. This is just kind of a basic, simple one. Certainly wherever you work or for whatever particular project you might have, you may want to have different fields than what we have here, but a couple of the fields we probably always need to have. First thing, just a project title. Just need something to be able to call the project. Project leader. So project leader is normally your Six Sigma black belt. Maybe if it's a small project, Six Sigma green belt that's actually leading the project. Then we want to know who the project sponsor or the project champion is. You need somebody from the management team that is supportive of this project. And if you don't have a sponsor or champion, then your project's probably in trouble because you need that sponsor or champion to help you obtain resources when you're trying to implement these projects. Any stakeholders that are involved, so stakeholders are other groups of people who may not be directly involved with the project, but who may end up having to deal with the results, the implementation of the project. And we'll go through an example and show you some examples of folks who might be stakeholders who aren't necessarily directly involved with the project. Then next we're going to take a look at the problem statement or the current state. This really is the heart of the define phase, the problem statement, where you're going to explain exactly what your current situation is and what the problem is with that current situation. This stage, the define stage, actually happens before the measure stage, but we might want to have at least enough data in the problem statement that we can quantify what the problem is. And maybe that's kind of a balancing act of, are you in the define stage or in the measure stage? But you need a little bit of data to really explain how big of a problem you have and just get some quantifiable evidence for the problem. Next, we're going to fill out the project description or the desired state. You just described how things are. Here you're going to describe how you want things to be. So what are you going to do in the project and what do you want the end result to look like? Some justification or benefits. We need to be able to define why we're going to invest some time, some resources into this project. So we need to be able to show that. Again, may have to do some measurements in order to fill out a good justification section. The deliverables needs to be a specific list of exactly what it is that you're going to deliver when you complete this project. Is a deliverable a new product? Is a deliverable a presentation? Is it deliverable a recommendation in a report form? What are you going to hand to your sponsor when you finish this project? Metrics are really important here. We need to be able to measure the current situation and measure the results from our Six Sigma project. And measure says we need to have some metrics. So here we need to define exactly what our metrics are, and if it's not clear, how you're going to measure those metrics. A little short section here for in scope and out of scope. This helps to make sure we don't have problems with scope creep. In other words, we want to tell exactly what we're going to consider in this project. That's what we call in scope, and what kinds of activities or what areas are not part of the project. We might want to list specifically out of scope. And we've got a section for budget. This might be expanded if we have a project that we're expecting to spend a lot of money on. But just as a minimum, capital expenditures that we're expecting, expenditures that we're expecting as part of the project. Schedule, same way. We might want to expand the schedule section if we got other milestone date that we want to put in there. But at a minimum, we should tell our project sponsor when we think the define stage will be complete, the measure, the analyze, the implementation stage, and the control stage. Any kind of risk or obstacles that we see ahead of us. So let's just look at one that's been filled out. Here's a project for increased electric motor efficiency. We got a leader, a sponsor, stakeholders. Here's some stakeholders. Design engineering team responsible for designing new products. A test lab that's involved here because we need the test lab to actually perform some electrical efficiency tests for us. the production people, because they're going to be responsible for implementing any kind of production changes that are recommended by the Six Sigma project. So again, you think about, they're not maybe not directly involved because they're not working on the project, but they're going to be indirectly involved. As soon as the project's over, they're the ones who have to live with the process changes. Marketing group responsible for communicating design changes or communicating changes in performance, manufacturing, and product cost to customers. So the marketing folks, they're a stakeholder because they want to know what's going on and what is it that they're going to have to try to sell to their customers. Accounting responsible for capturing any deviation to current standard cost. So here's our problem statement. Here's what's going on. Baldor electric motor fleet currently average 93% electrical efficiency. The Energy Policy Act passed by the federal government requires electric motors sold in the U.S. to have an average electrical efficiency of 95%. Based on current performance, the majority of our fleet cannot be sold in the U.S. once the law goes into effect. So you see there's been a little bit of measurement already in place. We know that our current average is 93% electrical efficiency. So obviously there's some measurement that has been done. That helps us to quantify how far are we. We're at 93%. We need to get up to 95%. That leads us right into our project description or our desired state. What we want to do is we want to increase electric motor efficiency to 95% without adding active materials. Develop manufacturing process alternatives that will increase motor efficiency from 93 to 95%. Again, some quantitative data there. Provide test results sufficient to nameplate our products at 95% efficiency rating. So that gives us a pretty clear view of what we want this project to achieve. The justification is that the increase in electrical efficiency is required by the federal government legislation. It's an attempt to lower the U.S. electrical power consumption. It falls under conservation of energy policy. One thing for our marketing group, individual customers are going to benefit from increased motor efficiency because that means their power consumption, their utility bill is going to be less if we can increase the efficiency of these motors. Deliverables, what is this team going to deliver? They're going to deliver the design criteria for a redesigned motor. So exactly what materials go into the motor, any kind of drawing changes, standard operating procedures for any manufacturing process changes. So these standard operating procedures is just a document that explains how the manufacturing process is accomplished. Estimated production cost of new design. So part of this, the responsibility of this team is to work with accounting and to come up with an estimate for what the new design is going to cost to produce. And then test results illustrating before and after motor efficiency. You can probably tell from those deliverables and from the project description, some of the metrics that we're dealing with is electric motor efficiency as defined by watts out divided by watts in. Product cost as defined by accounting standard cost to include all cost of goods sold expenses. So again, when we list metrics, if it's not clear how they're measured, we want to define exactly how they're measured so we don't have two different groups measuring something two different ways. A couple notes here for what's in scope and what's out of scope. What's in scope are the raw material specifications to make these motors, the manufacturing processes. It says operator training. So part of this project is going to include the project team training manufacturing operators on any kind of process change that they recommend. What's out of scope, things that this project team is not going to deal with, is exemptions to the policy. This Energy Policy Act, some motors are exempt from it, and this team's not going to deal with that. Somebody else is looking at which motors are exempt from the policy. The team's not going to deal with marketing or advertising, communicating the proposed changes. We're going to leave that for the marketing group. Budget, no expected capital expenditures, but there's some expense money, at least some R&D money going on here. Lab time for testing, they estimate $8,000. Prototype manufacturing costs, so they're building some prototype motors. They're estimating that's going to be $25,000 for a total project cost of $33,000. And then schedule we talked about, at a minimum, we at least want to tell when we think each of these stages are going to be complete. So define happens January 15th, 2 weeks to get the measurement stage complete. Looks like a month to do the analysis stage, another month for the implementation stage, and 2 more weeks for the control stage. Risk or obstacles that are involved, the inability to increase electrical efficiency without adding conductive materials and cost. So that is one risk that this team had to recognize, is that they may not be able to increase electrical efficiency without adding those active materials. That's the objective, is to increase efficiency without adding the active or conductive materials. But a risk is maybe they can't figure out how to do that. Another risk is scheduling lab test time. There were a lot of prototypes being built and tested, and there was some concern about if all those could be tested in time. So we just got a note here that it might require overtime, and it might also require outsourcing some of the testing, some of the lab services. Another risk is changing the manufacturing process in a manner that will add unacceptable levels of labor costs. Basically, the team recognized from the beginning that we're probably going to add some manufacturing labor, but at some point, maybe it becomes unacceptable. We can't sell a motor that costs more than what we can get our customers to pay. So those are the obstacles or risks. Again, a Six Sigma project charter. I'll put a template there for you that you can use. Modify this as fits your project and your particular organization.